Hi friends, today we'll discuss about chapter number 2, Boolean algebra. From this lesson, for annual exam, you'll get two 2-mark questions and one 5-mark question you'll get. Total you'll get 9 marks. The chapter title is Boolean algebra. So we all know that now computers normally use binary numbers. So in this chapter, we are going to learn about the algebra that deals with binary numbers. That's why this chapter title is called as Boolean algebra. It means the algebra which deals with binary number systems is known as Boolean algebra. In this lesson, we learn how to use Boolean algebra to design simple logic circuits like ALU, right? So, a brief history about this chapter, that is, long ago, Aristotle constructed a complete system of formal logic and wrote 6 famous works on the subject, contributing greatly to the organizations of man's reasoning. Long back, Aristotle constructed some formal logic and he wrote 6 famous works on this. For centuries afterward, mathematicians kept on trying to solve these logic problems using conventional algebra, but only George Boole could manipulate these symbols successfully to arrive at a solution with his own mathematical system of logic. After the contribution of Aristotle, the mathematicians have started solving the problems, the logical problems, but the success was gained by a person called as George Boole. He manipulated that problem successfully. Boole's revolutionary paper, An Investigation of the Laws of the Thought, was published in 1854. The George Boole's paper was published in 1854, which led to the development of a new system, the algebra of logic, that is, the Boolean algebra. It means the history of Boolean algebra began in 1854. The Boolean algebra was introduced in 1854, but till 1938, no one has used this. But in the 1938, when Claude E. Shannon wrote a paper titled A Symbolic Analysis of Relay Switching Circuits, in this paper, he applied Boolean algebra to solve relay problems. A person called as Claude Shannon has used this Boolean algebra in the telephone switching circuits for solving the relay problems. As logic problems are binary decisions and Boolean algebra effectively deals with these binary values, thus it is also called as switching algebra. So one more name we are concluding here after the brief history of that. So in this introduction part, what you learned is the Boolean algebra means the algebra which deals with the only binary numbers. Using binary numbers, we are solving the algebraic problems, that we call it as Boolean algebra. In the year 1854, George Boole has introduced this name as Boolean algebra, but his development was used in 1938 by Claude Shannon in a relay switching circuits to solve the relay problems. That's why this one more name for is given for Boolean algebra is switching algebra. Nowadays, it is a backbone of electronic industries. Even in our computer science, the Boolean algebra becomes the backbone of computers. So after knowing the brief introduction of that, we move on to a small heading called as binary valued quantities. In this, variables and constants will learn. So every day we have to make logic decisions. For example, every day when you get up, before sleeping in the night, many logical decisions will take. Right? For example, should I carry the book or not? If you are going for a school or college, then you will sit and decide before leaving home whether I have to carry this book or not. Then, should I use calculator or not? If you are performing some mathematical operations, then at that time, we'll check that whether I'll go for manual or shall I use calculator for this particular problem. Again, the answer is yes or no only. Then in the relaxed time, should I miss a TV program or not? In the relaxed time, whether I have missed today's TV program or not. Each of these questions requires the answer either yes or no. These are the only two possible answers. Should I carry the book or not? Either yes maybe or no maybe the answer. Shall I use the calculator or not? Again yes or no is the answer. Then I miss TV program or not? Again the answers are yes or no. It means all the three questions answers are either you'll get yes or no. Therefore, each of the above mentioned is a binary decision. Binary decision making also applies to formal logic. It means binary means only to either 1 or 0, high or low, true or false, yes or no. These are the binary valued quantities. Then, a variable used in an algebraic formula is generally assumed that the variable may take any numerical value to the entire field of real numbers. We know that a variable means it is a quantity which will change during the execution of a program. That's why a variable may have any numerical value, right? However, a variable used in Boolean algebra or Boolean equation can have only one of two possible values. Only variable can have any values, whereas in Boolean algebra, a variable can have only either of these two values. Either you can say yes or no, that is true or false, right? These two logical values the variable can hold in the Boolean algebra. So based on that, you can say that, see, the decision results into either yes or no, that is 1 or 0 is called as binary decisions. Whatever the decisions for the questions, logical questions, you'll get either yes answer or no answer. That we call it as a binary decisions. Also, if an equation describing the logical circuitry has several variables, if an equation is going to describe the logical circuit, then that has several variables, it is still understood that each of the variables can assume only the values 0 and 1. Whatever may be the number of variables in the equation or in the logical circuitry, but their values must be either 0 or 1. For example, if you take a plus b equal to c, each of the variable a, b, c may have only the value 0 or 1. This is all about the binary valued quantities, that is variables and constants. What is a constant? Constant is a variable or a quantity which will not change its value during execution of the program. Then comes one more heading called logical operations. There are some specific operations that can be applied on truth functions. Before learning about these operations, we must know about compound logical functions and logical operations. Before knowing the truth functions, we should study about the compound logical functions and logical operations. Now, to do that, we'll go with logical function or compound statement. The algebraic variables like ABC or XYZ etc. are combined with the help of mathematical operators like plus, minus, into, slash to form algebraic expressions. For example, 2 into A plus 3 into B minus X equal to open bracket 10 into Z close bracket slash 2 into y, that is 2a plus 3b minus 6c equal to 10z by 2y. Similarly, logical statements or truth functions are combined with the help of logical operators like and, or, not to form compound statement or logical function. So in the above stated, the algebraic expression, if you use and or not along with this, then that becomes the logical function. These logical operators are also used to combine logical variables and logical constant to form logical expressions. The algebraic expression contains the logical operators, means that we can call it as the logical expression. For example, assume that x, y, z are logical variables. The logical expressions are x, not y, or z. This is one logical expression because this expression has the logical operators known as not and or. That's why I call it as logical expression. Y and x or z. In this, again, and or are the logical operators. That's why you can call this as also a logical expression. Then we start with the logical operators. Truth table is a table which represents all the possible values of logical variables or statements along with all the possible results for the given combination of values. So it means what we are defining here. What is a truth table? Truth table is nothing but it represents all the possible values of logical variables or statements along with all the possible results in a single table. That table you are calling it as a truth table. It means truth table contains a different combination of logical values along with their results. That we call it as a truth table. For example, if x and y are the logical statements and r is the result. Here x and y are the two logical statements and r is the results. Then the truth table can be written as here. This is called as truth table. This truth table can be written as, right? Say this truth table can be written as x may be 0, y may be 0, x may be 0, y may be 1, x may be 1, y may be 0, x may be 1, y may also have 1. At that time, the results are 0, 0 means 0, 0, 1 means 0, 1, 0 means 0, 1, 1 means 1. It means the truth table of AND operation. It means logical multiplication will take place here. 10. Exam point of view for 2 marks. Two important definitions are, based on this, you can say that define tautology and fallacy. define tautology and fallacy. What is tautology and fallacy? If result of any logical statement, if the result of any logical statement or expression is always true, then it is called as tautology. Then what is fallacy? If the result of any logical statement or expression is always false, then it is called as fallacy. For exam point of view, these two definitions are important for 2 marks question. Then after this, we start with the operators. As we all know that there are 3 basic operators you'll get. One is called not operator, next one is called and operator, and third one is called as or operator. These 3 are logical operators that we'll study in the next class, right? So don't forget to subscribe this PU CS World channel to get the updated topics. Thank you one and all.